Hello, today I'm explaining the synapse using an example of two girls texting each other. Believe it or not, neuron communication works almost exactly the same way. Imagine girl A is texting another girl, girl B. They aren't physically connected, just like neurons aren't touching. The airspace between their phones is the synaptic cleft, the tiny gap between neurons. A synapse is a junction between two neurons where communication occurs. The presynaptic membrane is the sending neuron. The postsynaptic membrane is the receiving neuron. The presynaptic membrane is part of the sending neuron. It is located at the end of the axon in the axon terminal. It contains synaptic vesicles filled with neurotransmitters, which are text messages, and when an actual potential arrives, like a send button is hit, this membrane releases neurotransmitters into the synaptic cleft, and a message is sent. Synaptic vesicles are like drafted text messages waiting to be sent. They store neurotransmitters, the actual messages. When the signal comes, they move to the edge of the presynaptic membrane and hit send. Once triggered, they fuse with the presynaptic membrane and release their contents into the synapse. The postsynaptic membrane is part of the receiving neuron, or that girl's phone. It has specific apps and notifications, which are receptor proteins, and trigger messages with certain responses. Synaptic transmission begins when an action potential travels down the axon. The action potential is like girl A deciding to text. The electrical impulse travels down the axon, like her typing with urgency, until it reaches the phone's send button. When it reaches the axon terminal, depolarization occurs. This opens voltage-gated calcium channels. Calcium ions flood into the cell, which triggers synaptic vesicles to fuse with the presynaptic membrane. Neurotransmitters are then released into the synaptic cleft. When the action potential reaches the terminal, voltage-gated calcium channels open. Calcium rushes in and primes the vesicles to fuse with the presynaptic membrane to release neurotransmitters. Calcium is like the finger pressing send. Without calcium, the message never goes out. At the release zone, neurotransmitters diffuse across the synaptic cleft. This is like messages going across Wi-Fi. They travel through the synaptic graph. They bind to specific receptors on the postsynaptic membrane. This binding opens or closes ions channels, changing the membrane potential of the receiving neuron. Sometimes not all messages get sent. Reuptake occurs when transporter proteins take neurotransmitters back into the presynaptic neuron for reuse. Other times, messages can be deleted. This is like enzymatic deactivation, when enzymes break down the neurotransmitters in the synaptic cleft. Some texts can hype you up. OMG, guess what? When someone texts you that, it's really exciting. That is like glutamate in a neuron, which triggers action potentials. Glutamate is an EPSP. Other texts can calm you down. When someone says, get back to me when you can, or it's not a big deal, it's inhibitory, like GABA and IPSP. One increases the chance of an action potential or a response, and the other decreases it. Excitatory postsynaptic potentials, or EPSPs, are small depolarizations that make the neuron more likely to fire. Texts that make girl B more likely to immediately respond. They bring her closer to an action potential. Inhibitory postsynaptic potentials, or IPSPs, are hyperpolarizations that make the neuron less likely to fire. texts that make her pause or ignore the phone. They move her further from action potential. If another EPSPs are added together, the neuron will fire an action potential. However, IPSPs can reduce or cancel out EPSPs. The overall balance between excitation and inhibition determines whether an action potential occurs. Temporal and spatial summation determines whether the postsynaptic neuron reaches threshold. Temporal summation is like when girl A sends 5 texts in a row. Hello, are you there? Answer me. If enough messages come quickly, girl B will get more alerts and is more likely to respond. Spatial summation is like a group chat where multiple people are texting girl B at the same time. The more notifications she gets, the more likely she is also able to pick up her phone. The brain adds all these signals together um, in order to release an action potential. That is my presentation, and I hope it was very clear and you were able to now understand the process of neurons firing.